All right, so the next lesson in this unit is on another form of linear functions, and this time it's called general form. Okay, so to start off here, yeah, it's got the kind of formula or the layout for general form written here. So general form of the equation of a linear relation, okay, is ax plus by plus c equals 0, where a is positive. Okay, so the number in front of the x must be positive. And a, b, and c are integers. Okay, so integers means no fractions or decimals. Okay, so so what you'll notice here is there's a number in front of the x, number in front of the y, add to a constant number is equal to 0. Okay, so first example here, we're just going to write each equation in general form. Okay, so y equals negative 1 over 4x plus 3. Okay, so this equation right now is in, if you recall, slope-intercept form. And what we want to do here is we want to convert it to general form. Okay, so what we're going to do is use our knowledge of equations and what to do with equations to, the key thing about equations is whatever you do to one side of an equation, you're going to do it to the other side. All right, so so to start off here, what I'm going to do here is I want to deal with this fraction, 1 over 4. And to get rid of the 1 over 4, what I can do here is multiply both sides by 4 itself. Okay, so if you imagine the multiplying both sides by 4, on the left-hand side, we have 4 times y, which is 4y. Now, on the right-hand side, I'm multiplying this side by 4. Basically, I'm going to distribute the 4 in and multiply each one of these terms. All right, so the first term there, negative 1 over 4 x. I'm going to multiply this by 4. So I'm actually going to just put the 4 out in front. And then the plus 3, I also need to multiply that by 4. All right, so again, just using that rule that we know about equations, whatever you do to one side, you got to do to the other side. Here, it's called balancing your equation. And what that breaks down is you're going to multiply both sides by the same number. Basically, what you're doing is you're multiplying each one of these terms by that number. All right, so now if we work this out, the 4y, I'm just going to leave it as 4y. Then over here, 4 times negative 1 over 4. Well, this is the same as 4 over 1. Right? So if I have 4 times negative 1/4, these 4's actually cancel, and we have negative 1 result. So this is going to be negative x. And then 3 times 4 is plus 12. All right, positive 12. All right, so again, once you see a fraction there, what you want to do is you want to multiply both sides by the denominator. All right, so now to get it in general form, what I want to do here is I want to move everything to one side. So the negative 4x, I'm going to move to the left side as well as the plus 12. All right, so when you switch sides, you switch signs. So the negative x becomes positive x. Then I'm going to write the plus 4y and then minus 12. All right, so that plus 12 becomes negative 12, and this is going to equal 0. Now the equation is in general form. All right. All right, so what I'm going to do here is actually, before I go on to the next part here, I'm going to use the old graphing calculator there that I showed you in the last lesson, Desmos. And basically what I'm going to do here is I'm going to graph each one of these equations, just show you that they are actually the same. All right, so for instance, let's take a look at this. Copy and paste. No. All right, so I'm just going to copy that onto here. And you'll see that it graphs the line that will start that within slope-intercept form. All right, so theoretically, if I punch in the equation that we found here, x plus 4y minus 12 equals 0, since it's, it is supposed to be the same equation or same graph or same line, it should overlap the one that we have here. So, so x plus 4y minus 12. So x 4y minus equals 0. Right, so you'll see there, the red line there, it used to be a red line, is now a blue line. The reason it changed to blue is because it's overlapping. So the thing about this Desmos is I can click here. That means don't graph it. Right, so I'm back to the red one. Notice that, yes, it does overlap. All right, so what that means is that the graph of the first one is equal to the graph of the second one. So these are both the same equations, or sorry, I keep saying equation. These are both the same functions, just different forms, right? Different equations. Graph the exact same line. Cool. All right, so let's try this one here. Now this one, rather than being in slope-intercept form, this is now slope-point form. So again, this is slope-point form, which is what we learned in the last lesson. All right, so again, I want to change this over to general form. All right, so again, we're dealing with the slope here is 3/2. So I have a 2 in the denominator, I have a fraction here. So what I'm going to do, just like I did before in the previous example, is I'm going to multiply both sides by the denominator, which is 2. All right, so since there's 2 terms on the left side, I'm just going to multiply the 2 in. So on the left-hand side, I got 2y plus 4 equals. Now on this side, this 2, this 2, if I multiply everything by 2, basically I'm multiplying the coefficient there, 3/2 by 2. Okay, so this is one term because the 3/2 is being multiplied with this set of brackets. So you can consider this one term. So, so what that means is that, yeah, 3/2 times 2 is equal to 6/2. Right, because 2 is the same as 2/1. Right? So whenever you multiply, so basically I'm multiplying 3/2 with a 2/1. That becomes multiply top 6, and the 2 times 1 is 2 on the bottom. And I still have the x minus 4. So again, 2y plus 4 equals. So now 3 divided by 2. This right here, or sorry, 6 divided by 2 is going to equal 3. That I can replace with a 3. I have x minus 4 in the brackets. All right, now to get this to look like it's in general form, I need to get rid of the brackets. All right, so that's what I'm going to do next. So multiply 3 in. 2y plus 4 equals 3x minus 12. And now let's move everything. We're going to move both these terms to the left side. 10 convert. So, so yeah, the 3x and the negative 12, we're going to move it over to the left side. So that becomes negative 3x. Write the plus 2y, equals the plus 4, and the plus 12, right? So negative 12 moved to the other side, that's plus 12 equals 0. So if I collect my like terms, negative 3x plus 2y, I add the 4 with the 12, that's plus 16 equals 0. All right. Now you may think that this is in general form, but technically it actually is not, because if you recall, if I scroll back up here, general form of the equation, this a has to be positive. So the number in front of the x is always going to be positive. Notice here that this number here is negative, right? It's negative 3. So the way to get around that is basically you're just going to multiply both sides, or multiply through by negative 1, which essentially means that you're just going to switch all the signs. All right, so this becomes 3x minus 2y minus 16. And then that now is in general form. All right, so yeah, should we check this one again with the Desmos? I think I will quickly. So let me just copy and paste this one. All right, so in green here. All right, so this is the original, or this is the graph of the line that was given in the question. And then below it, I'm going to punch in what we got as the answer. So 3x minus 2y minus 16 equals 0. Equals 0. All right, so yeah, so what you notice is that the purple line here now overlaps the green. If I toggle it on, off, you'll see that it changes the color. That basically means that these are, again, the exact same graph, just two different equations. So two different forms. Yeah. And yeah, so for part B here, again, make sure the number in front of the x is always positive. Cool. All right. So next up, we're just going to look at some questions that we can answer when we're given a linear function in general form. All right. So one of the advantages of when it's in general form is that it's actually easy to find what we call the x and y intercepts. All right. So a little bit of review. Hopefully it's review. Your x and y intercepts are where it crosses the x and y axes. All right, so your x-intercept is where it crosses the x-axis. Your y-intercept is where it crosses the y-axis. All right, so what that means on a grid here, if I was to draw a random line, so this is not specifically the one in the question, but let's just say I draw a line like, I'm trying to position myself, something like this. All right, so what that means is that this, wherever it crosses here, this is your x-intercept. And then where it crosses here is your y-intercept, okay, on the graph. Now, to find out what they are, values where it actually crosses, what you'll notice here is that along this line, your x-intercept, this value for the y is 0. So you notice that this is -1, would be -2, but that would be 0 right on that line. This would be, for value to, let's just say 1, and perhaps 2 there. Okay, so the key thing here is along this line, this x-axis, your y value is 0. Okay, so hopefully that makes sense. So again, along the x-axis, y is always equal to 0. And likewise, right, if I was to go up and down, this is the y-intercept. What you notice is that all the y coordinates along this y-axis, your x is equal to 0. So, yeah. All right. So, for instance, actually, you know what? This might be a better way to explain it. So, this point here is at 0, 2. This point here is 0, 1. This is 0, 0. This is 0, -1. This point here is 0, 0, -2. So notice here that all your x values, all the points along this y-axis, all your x values are 0. Okay, so that's why along the y-axis, your x is 0. Okay, so it's kind of like the opposite. So if you're trying to find the x-intercept, you're going to set your y to 0. So this is to find the x-intercept. And then likewise, to get your, along the y-axis, or get your y-intercept, your x is 0. All right, so what does that mean when it comes to solving or finding the x and y intercepts of this specific function, linear function? Basically, all we do here is to get the x-intercept, right, so what that means is that to get the x-intercept, I'm doing a terrible job of printing there. All right, so to get the x-intercept, this means that you're going to plug in 0 for y into the equation. So the way that's going to look here is that I'm going to have 3x plus 2. Now for the y, right, so I'm trying to find the x-intercept, plug in 0. And then minus 12 equals 0. Now if I solve this equation, I should get the x-intercept, all right, because I plugged in 0 for y. Now, key thing here is 2 times 0 is 0, and if I add 0 to anything, it's like it's not even there. Right, so basically what I'm saying here is that we can just cross this term out. That's 0, and anything plus 0 is still the same. It doesn't change anything. All right, so basically what you're left with here is you want to solve 3x minus 12 is equal to 0, and solve for x. So to solve for x, we're going to move the negative 12 to this side. 3x equals positive 12. And then to solve for x, I'm going to have to divide both sides by 3. So do that. All right, so these cancel. And therefore, what that means is that the x-intercept in this case is equal to 4. Right? So for this graph, the line will cross the x-axis at 4. Again, going back to the, I know this might, you can kind of ignore this. I was just explaining like the concept of the x-intercept, y-intercept, but this green line here is not the line. That's it. That's this line here. Okay, so let's just be clear on that. This is just used as an explanation, all right, for what x-intercept and y-intercept is. All right, so in terms of a point, this is the point 4, 0. Okay, so that's the x-intercept. Likewise, to get the y-intercept, we're going to plug in 0 for x. All right, so what that's going to look like here is that you're going to go 3 times 0 plus 2y minus 12 equals 0. All right, so again, this time instead of plugging in the 0 for the y, we're plugging 0 for x because we're trying to find the y-intercept. And again, 3 times 0 is still 0. 0 plus anything is itself. So basically, again, this term just kind of disappears, and you're solving this equation. 2y minus 12 equals 0. Now to do that, I'm going to move the 12 over to the other side. So I get 2y is equal to positive 12. And then I'm going to divide both sides by 2. Y equals 6. So that means the y-intercept, right, where across the y-axis, your x value is 0, and your y value is 6. Right? So these 4, 0 is your x-intercept, 0, 6 is your y-intercept. And now just to confirm, that's what I'm going to do. I'm just going to use the old Desmos, if I can. Copy this. Let me just copy that and paste it onto Desmos. Okay, so let's take a look here. So this is the graph of the equation that was given us in line. So you'll see that again, the y-intercept here is at 0, 6, and the x-intercept is at 4, 0, which are the two intercepts that we got. 0, 6 was our y-intercept, 4, 0 was our x-intercept. All right, so that just kind of confirms it. All right, cool. Now the next part here, determine the slope of the line. So, so again, 3x plus 2y minus 12 equals 0. X minus 2y plus 12 equals 0. Okay, so this is, I wrote that down wrong. Let's do that. All right, it was 3x plus 2y minus 12 equals 0. All right, so to determine the slope, what we need to do here, we need to change this to slope-intercept form. All right, so remember the y equals mx plus b. Now to do that, what we need to do is we need to isolate the y. All right, so what that means in terms of steps, so please follow along here. So I want to get this y by itself. So the first thing I'm going to do here is I'm going to take the 3x and the minus 12, and I'm going to move it to the other side of the equation. All right, so when I do that, I'm going to have the 2y left over. Now it's going to equal negative 3x plus 12. All right. And then to isolate the y, right now I got 2y, so to isolate the y, I'm going to have to divide each one of these numbers by 2, each one of the terms by 2. And as a result, 2 divided by 2 is 1. 1 times y is just y. The next here, I got negative 3 over 2x plus 6. All right, so from here, once I've isolated and changed it to slope-intercept form, I can see that the slope is going to equal negative 3 over 2. Now, I think I still have that. Yep, so I still have this equation boxed in. So let's just check this. All right, so again, it's a negative slope. Right? Good thing, that's what we got. And if it was 3 over 2, so if I go down 3, I go over 2, you notice that, yes, it does hit that point there on the line. All right, so you can see visually the slope of this line here is down 3 over 2. So that's negative 3 over 2. Okay. All right, so part C, graph the line. Okay, so whenever you're graphing lines that are in, let's go back to here, general form, the easiest way to graph the line would be actually to find your two intercepts and plot them, right? Because you only need 2 points to graph the line. All right, so again, I can go 4, 0 is my x-intercept, 0, 6 is my y-intercept. So I'm just going to plot those 2 points. Okay, so my x-intercept was 4, 0, my y-intercept was 6, 0. Okay. And now, if I was to connect this up, not the straightest of lines. Let's try that again. All right, so I'm going to connect these up. All right, and then I can continue on. All right, so that would be the graph line. Okay, so basically, because you only need 2 points to graph a line, because the line will never change direction. It's always just straight. Now, the other way we could have graphed it is we could use the part B here. We could change this to slope-intercept form, all right, and graph it. We should get the same graph, right? So if once it's changed to slope-intercept form, you can see the y-intercept is 6, which is actually the y-intercept we got when we solved the equation. All right, so, and then you have a slope of negative 3 over 2. So yeah, perhaps some green here. I'll show you, lap this one. So if you wanted to use the slope-intercept form, I would start at the y-intercept of 6, and then I would go down 3, 1, 2, 2, and then down 3 and over 2. So you see here that it, once I plot these points with the slope, it does actually hit this x-intercept of 4. I can go up 3 over 2. Or I can go from here, I can go down 3 over 2 and so on. You can see that, yes, the points that I get here when I do this, start at the y-intercept and go down 3 over 2, it does hit the points that I graphed with the 2 x-intercepts, or sorry, the 2 intercepts, which is the x-intercept and the y-intercept. All right. Cool. So either way, right, you can use slope-intercept. You can convert it to slope-intercept form and graph it that way if that makes you feel comfortable. Or you can just find the 2 intercepts, plot those 2 intercepts, and then draw a line through it. Cool. All right, guys. So that is the lesson on the general form of linear function.